Okay, let's move on to the next part. Okay. Okay, the next one. Next one, Na here just represent the element metal, reactive metal, sodium. That's all. Okay. Now, this is a reaction between the alcohol and your reactive metal sodium here, and we are using or considering the alcohol as example of a Bronsted acid. Okay. You might not know what is Bronsted. Do you know what is Bronsted acid? You should know because I taught that in December. You know what Bronsted acid? Can you define for us? Very good. It's a H plus. Get the donor. Okay, it actually loses the proton. So this definition of Bronsted acid is actually very similar to Arrhenius, the O-level definition where acid dissociate and release H plus in water. Right, so things like that. Okay, so of course this definition about Bronsted acid and another definition which is called Lewis acid will be taught in acid-basis equilibrium, but not today lah. Okay, but this one later you can take down. All right. So basically, okay, sodium metals, and then you all copy down whatever first later I shift. Okay. So if you want to replace with any reactive metal, actually you can. Just that they always use sodium for illustration. Can you replace with potassium? Of course. Okay, can? All right, so let me show you the equation then. It's basically just acid metal reactions here. I give you the product over here. Let me write the overall equation. So it goes in this way. I have your ROH, right? I plus your sodium here. Full complete reactions here. Proton donor, it loses the H plus, right? So become RO minus Na plus plus half a mole of H2 gases. Okay, basically this is the salt form, right? The salt and H2 gases, like what we learned in O levels. Okay, and how we highlight the half. Why do you want to highlight half? Temperature law will tell you in substitute. Okay, if you have one alcohol react with Na, it will give you half a mole. If we have a diol plus excess Na, give you a salt plus, okay, Craydon, how many moles of H2 do we get? Assuming this is 1 mole. If you see that one, if you only have one OH, right, you will release only half a mole of H2. If we have a diol meaning in the molecule, how many OH are there in the diol? 2, very good. So if you have 2 OH reacting with sodium, right, for example, like that, diol, right? Okay, you form a salt in which both the O will become alkoxide. So what is the mole of H2 that you get? 1, that's all. So that is usually asked in MCQ only. Is it okay? So how many highlight half a mole? That's all. Okay, move on. Okay, move on to O. Want to guess what is O? Kapita, guess what do O represent? Very good, oxidation. Okay. Now, alcohol can undergo oxidation, right? Okay. Now, from O level, can you suggest some of the common oxidizing agent? Like, that give you one that you can recall. Maybe not O level, but we have come across oxidizing agent in when we do the mole, right, back in J1, right? Very good, KMO4. Okay. Can you suggest another common oxidizing agent besides purple potassium manganate? Can you recall? Cannot recall. Orange color? Orange one? Orange? Yeah. The Br2 is, let me think. Okay, halogen is also an agent, but it's not commonly used. Yeah, so I want one that is always very common and always brought up together with the KMO4 one. Also potassium something. Not KOH, but good at that. Come. I want more response from the rest of you. Very good. I don't ask him because he has my coach's copy from I taught his sister previously, so he has the book. So I don't ask him. He confirm no, you just read out only, right, John? Potassium. So this it will change color from orange to green. Potassium. Okay, very good. Potassium. See what just now Sodium say? Dichromate. Dichromate. Okay. Now then, after that, O level. Can you tell me, because O level we learn oxidation of alcohol, just that it's not in combined. So I need the help from three of you. In O level, alcohol undergo oxidation to give you, John, you can say this. In O level, yes. We only learn that in O level, right? No matter what alcohol they give you, it will always be oxidized to your carboxylic and nothing else. That's what we learn in O level. So meaning your alcohol undergo oxidation to give you carboxylic acid. That's what we learn in O level, right? Regardless of how your alcohol look like, right? But then now we will tell you that depend on the structural formula of your alcohol, whether it's primary, secondary, or tertiary, right? It will affect the product we form. Not all of them will give you acid, only a particular feature. So we need to learn that. Is it okay? Okay. Can you help me copy this down first? Then after I'll explain, okay? So the possible one we have is acidify K4 heat under reflux, okay? The PC is the same acronym we use it in O level. Can you recall for me? If you can recall, what does the PC represent here? Cannot recall. Can you recall? I guess I don't never mind. Are you sure you remember that much? Remember or not? Okay, the PC. It's a color change. Oh. Yes, very good. Okay. Now, can the one help me out here? Okay, some school they need you to tell them exactly what is the acid you need to use to provide the acidic medium. So, very good. Dilute sulfuric acid. So, if your school need you to state the exact acid for the medium, you write down KMO4 equals in dilute H2SO4. But for Cambridge, they are fine with the word acidify. I think for your school it's okay, right? Yeah, so you stick with this one, it's okay. But for your school, somewhere, I don't know, you have to double check. Are they okay with you writing acidify, or you need to state exactly dilute H2SO4? Dilute and then you, on top of the word acidify, you write down dilute H2SO4. How about you, Clayton? Your school okay with the word acidify? It's so. You think so, huh? Or maybe you just to play safe, on top you bracket dilute sulfuric acid. How about that? Just in case, you know, you don't want them to mark you down because you try acidify, right? Okay, OG means orange to green. Okay, so heat under reflux, here the reflux. Yeah, do the difference between the reflux setup with distillations over here. How many do all the necessary same thing? If I highlight this as well, I'm going to take some parts to show you. Is what color? Pink color. This one. This is reflux. Okay. Okay. Take two down already or still taking down? Two down already, yeah. Okay, let me show you the reflux setup versus the immediate distillations, okay? Okay, this is an example of your the big dark one. Okay, this is the reflux setup over in which the condenser is placed in a vertical manner. Okay, basically we do all you have to do is this one is to just condense any vapor back to your round bottom flask to ensure that you can have prolonged heating even overnight, so with no loss of volume basically, right? Then the normal distillations in which the condenser is placed in the slant manner here, which allows you to distill it out and collect whatever liquid that you want. Okay, Ken? And then here usually we have a thermometer because what happened will be why you need a thermometer there, right? Is for you to measure the temperature. So, for example, here, right, the moment the boiling point hit the temperature of the aldehyde that you want to synthesize, right, you stop heating and then you allow the vapor to distillate out. But for here, reflux system, though, there's no need for you to have a thermometer. I don't care. I just heat it overnight. So usually in university, last time, I'll just run reflux system overnight. So maybe I run it at 8 p.m. Then the next day, when I return back to lab at 10, then I turn off the whole thing. That's all. Okay, okay, yeah. So that is a bit between reflux as well as distillations. Okay. The diagram can be easily found online. You just Google reflux versus distillation, so should be fine. All right. Now, then I have this. Okay. Now, let me explain first before you take down. Okay. Now, when you have a primary alcohol, you can either oxidize halfway to an aldehyde. Okay, I pause first. Can you elaborate to me how does aldehyde look like? We learned it in intro. If you don't learn intro, right, maybe you want to help out. Since your memory is like very fresh compared to the rest of us. Your school learned just cut intro, right? No, long ago, 1 month, 2 months ago, in October. Or maybe one of you can help me out here, aldehyde. How does aldehyde look like? Okay. This is the alcohol. Okay. Rather primary alcohol, right? For example, this is 100, right? Okay. I can oxidize it to an aldehyde, and aldehyde look like this. So changing this CH2OH here to C double OH. This is an aldehyde. Okay. And after that, this aldehyde can continue to be further oxidized to something we are more familiar with, carboxylic acid, where you have one more oxygen over here. All right. Okay. So looking at the number of oxygen, right? We definitely can predict, right? Oh, from the primary alcohol to this aldehyde, is it complete oxidation? No, it is called partial oxidation. Okay, then this is further oxidized. Further oxidation. Okay, so if you want to have complete oxidation, it should, the endpoint should be this one. Okay, can you understand now? All right. Over here, I've written down in terms of name like that, but if you that it make more sense, for you to draw a separate formula, please replace with this one. Because ultimately, this is yours to keep. You understand what I'm about? So you can always improvise, you can always change the way I present. You don't like words, you do this. Okay? Can? Alright. So then what all this numbering over here? This one I don't know if you can see on number 3. That means if you want to stop at aldehyde, we can only use the one highlighted just now, which is dichromate with immediate distillations. Okay, that means you don't heat it for very long. You heat until the boiling point of aldehyde is good, then you stop heating. Okay, control heating basically. From aldehyde to carboxylic, you can use the first one or the second one, doesn't matter. You want to jump from primary all the way, zoom, this bypass the middle portion, zoom all the way to your endpoint. You can use the first one or the second one. So the third one is only for these special case. That's all. Can? Is it okay? But I pause first. You take out the first one first, later on I'll illustrate this one on the board as well. Can? Secondary. Okay, let me explain a little bit more using layman terms. Okay, reflux heating. Okay, or sometimes they say heat under reflux. Okay, layman terms basically you are heating for a long period of time to ensure complete reaction. The moment you write heat with immediate distillation itself, it is controlled heating. Okay, where thermometer is essential there. You need to see the temperature. The moment the aldehyde temperature boiling point is shown by on the thermometer, you have to stop heating. If not, the aldehyde will continue to undergo further oxidation to give you this things like that. Is it okay? So this one, if you feel that it's good, write down in layman terms. Okay. Now this is a secondary alcohol, right? Now whether you reflux or immediate distillation, no matter what, it will give you this. Okay, but we don't use heat with immediate distillation because when you use this one here, right, it's not a guarantee that all the secondary alcohol will be completely oxidized to ketone. That's why for this one here, we always say one or two over here, not the highlighted one. Is it okay? We always use heat with reflux because prolonged heating ensure complete reaction. Okay, tertiary is inert to oxidation. All right, this is most of the time. Okay, and in A level, there's always missing for the gray region, right? The gray area. So if the question tells you that, oh, this is a very special tertiary alcohol, it can be oxidized. Please follow the question. Is it okay? If the question don't say anything exceptionally right, we just assume tertiary is inert oxidation. Is it fair enough? Enough. Okay, I pause. Okay, okay. Is there any question to ask me? No, okay. Is it okay? Can I told you already that from that very easy example one. Recalling is another whole new world, right? Drawing also. The drawing, okay. We don't really have much topic left with it. For organic, I think we are left with about 3 to 4. Physical, we are left with 3. Inorganic left with 1. None of it. Less than 10, we are done. And now it's only mid-January. So, which means that for us in Apple, by end May, we will complete all the syllabus in that. In June, the whole entire month we devote to revision. Right, it's always about who can start to revise first, but of course in Apple we don't want to like school rush just for the sake of revising early, we don't, right? Because if you're rush, you don't understand also no point, right? Right.